We have been talking about dividing radicals. And there were two ways. If the radicals divided cleanly, that is, they gave you a whole number, then you would just divide them and put the answer under a square root. So like root 51 divide root 3 divides cleanly to 17, so our answer would be root 17. This divides cleanly to root 9, so we would just do the division. However, we did encounter ones where we couldn't divide. Okay, where we actually had to simplify them or divide them by multiplying. And for this one, we always multiply by whatever the radical is on the bottom. And so we multiply the bottom by root 5 and the top by root 5. Bottom by root 7, top by root 7. The last case is what happens if there's more than one term in the bottom. Because if you think about it, don't write this down, but I'll just show you. You might think, oh, well, let's multiply it by root 5. Because there's root 5 on the bottom. Well, if you did that, you get 2 root 5 up top, and then on the bottom, you get 6 root 5 minus root 25, which is 5. Notice I still have a square root on the bottom. So that's not working. I can't do it that way. I need another way. I'm going to multiply again by something. And we actually did it in the last lesson. There was a multiplication that we did. I showed you two binomials that we multiplied by each other, where the answer was always a non-radical. And that expression is this. Do you remember what we called these two? Conjugates. Exact same terms, but opposite signs. When you multiply a binomial by its conjugate, when you do the 4 multiplications, the middle terms will cancel out. You'll be left with a non-radical number. So whenever we see more than one term, we have to multiply the top and bottom by the conjugate of the denominator. So some students get a little confused sometimes. They'll do plus here, minus here. It has to be the exact same. And remember, this might help you to put parentheses around the original, because it'll remind you that I have to do 2 multiplications up top, and I have to do 4 multiplications on the bottom. Okay, so up top, we're going to do 2 times 6, 2 times root 5. What is 2 times 6? Plus 2 times root 5? 2 root 2? 2 root 5. On the bottom, we have to do 4 multiplications. So 6 times 6, 6 times root 5, minus root 5 times 6, minus root 5 times plus root 5. And when we do that, 6 times 6, 6, plus 6 times root 5, 6 root 5, minus root 5 times 6, minus 6 root 5, and minus root 5 times plus root 5. Minus, right, it's minus root 25, which is just 5. Notice when we multiply the conjugates, the middle terms will always cancel each other out, so the square roots are going to disappear. So we are left with 12 plus root 5 over 36 minus 5, which is 31. Sometimes we were able to reduce when we were doing some of the divisions before. How do you know if you can reduce these? Look at all the non-radical numbers. Can you divide all of them by something to make them smaller? No. So this can't be reduced. You have to be able to divide all of them, not just 2 out of 3. So that's reduced. So for B, yeah, I'm just going to do that to remind myself. What would you multiply the top and bottom of this one by to rationalize the denominator, as in turn the denominator into a rational number?
5 plus, wait, no.
4 minus 6. The conjugate, same sign, same terms, opposite signs. And you do the exact same thing to the top. Go ahead and do those multiplications. So when we do the 2 multiplications up top, we should have 20 root 3. Oh. Minus 5 root 18. On the bottom, we'll have 16, and then minus 4 root 6 plus 4 root 6. And then minus root 36, which is just minus 6. So those cancel out. So we should be here right now. Twenty root 3 minus 5 root 18 over 10. What do you want to do next? Yes, this can be simplified. This becomes 20 root 13 minus 5 times, well, this breaks up into root 9 times root 2, which becomes 3 root 2 over 10. Which further simplified becomes 20 minus 15 root 2 over 10. So I've simplified all the radicals that I can. Last thing I have to do, look at all the non-radicals. Can you reduce them all? Yes, we can divide them all by 5. So we get 4, 3, and 2. Therefore, our final answer is going to be 4 root 3 minus 3 root 2 over 2. Okay. Any questions? We're doing okay. Let's have a look at the next one. Going to be a lot of multiplying going on in this one. I have to do 4 up top and 4 on the bottom. What am I going to multiply the top and bottom by here? 5 minus root 6. Root 5 minus root 6. So I got 4 multiplications up top, I've got 4 on the bottom. Root 2 times root 5 gives me root 10. Root 2 times minus root 6 gives me minus root 12. Root 3 times root 5 gives me plus root 15. And root 3 times minus root 6 gives me minus root 18. Divided by, and I know on the bottom, the 2 middle terms are going to cancel out. Root 5 times root 5 is root 25, or just 5. Then I've got minus root 30 plus root 30, and then plus root 6 times minus root 6 gives me a final answer of minus 6. I can take those out right away. Maybe in my next step, I'll do any simplifying. Can I simplify any radicals? That one. So root 10 minus, well, this becomes root 4 times root 3 to root 3. Can't simplify the root 15. This becomes root 9 times root 2, which simplifies further to 3 root 2 over the simplified bottom of negative 1. Can't collect anything up top because all of the numbers under the bracket, the square root signs are different. But I can simplify it a little further. Just like if this was 1, you just take it out, right? Well, if it's negative 1, you got to change all the above to negative, and you can take the denominator out. So it becomes minus root 10 plus 2 root 3 minus root 15 plus 3 root 2. And that's as far as you can go. Finally, we've got one that's got a variable in it. Well, what am I going to multiply the top and bottom of this one by?
Root 3x minus 2.
Minus 2
plus 2.
plus 2, right, the opposite sign. Root 3x plus 2. So 6 times root 3x is just 6 root 3x, plus 6 times 2 is 12. What's root 3x times root 3x?
9. Root 9.
Root 9x squared, which is just 3x. Then I get plus 2 root 3x minus 2 root 3x. Those cancel, and then at the last multiplication, I'll get minus 4. So right now, I've got 6 root 3x plus 12 over 3x minus 4. Look at all of the non-radicals. Can you reduce all of them? Is there something that you can make them all smaller? 2? All of them?
Oh, no.
Can't make that one, which means you can't reduce. See that? Okay. So that's what we call when we divide by a binomial radical. So just to wrap this up, when the denominator is a binomial that contains a radical, we rationalize the denominator by multiplying the numerator and denominator by the conjugate of the denominator. remember, conjugate of a binomial means same terms, opposite sides. Because if you didn't multiply by the opposite signs, you'd end up with still having radicals in the denominator, which means it's not fully simplified. Because remember, I said a radical is fully simplified if it's in a fraction. It can be a fraction as long as there's no square root in the denominator. Okay.